What if I told you a Connecticut mechanic took Buick's most boring economy engine and turned it into one of the most revolutionary racing power plants of the 1960s? We're talking about an aluminum V8 that Buick engineers designed for grocery runs and gas mileage, transformed into a 300-horsepower monster that dominated West Coast sports car racing. This is the story of how Carroll Smith outsmarted one of America's biggest automakers and revealed the hidden potential in an engine that Buick literally gave away. Picture this. It's 1962. At Riverside International Raceway in California, the thunderous roar of V8s fills the air as sports cars scream past the grandstands. But there's something different about Dan Gurney's car. While the other racers are running heavy iron block engines that weigh as much as a motorcycle, Gurney's machine sounds somehow sharper, more urgent. Under the hood sits an engine that shouldn't be there, a modified Buick 215 that's about to embarrass every purpose-built racing engine on the track. This is the incredible story of the Buick 215 aluminum V8 and how one brilliant mechanic named Carroll Smith saw what General Motors engineers completely missed. It's a tale of accidental genius, corporate blindness, and the kind of mechanical ingenuity that could only happen in the golden age of American racing. To understand why Carroll Smith's achievement was so remarkable, we need to travel back to 1960. General Motors was facing a problem. The horsepower wars of the 1950s had created massive, fuel-thirsty engines that were becoming harder to justify as foreign imports started eating into the American market. Volkswagen Beetles and British sports cars were proving that smaller, lighter, more efficient vehicles had a place in American driveways. Nanda 10N Buick's response was revolutionary for an American manufacturer, an all-aluminum V8 engine. The 215 cubic inch power plant was a radical departure from everything Buick had built before. Where their traditional V8s were massive iron blocks that could anchor a boat, this new engine weighed just 318 pounds fully dressed. That's 232 pounds lighter than Buick's own iron small block V8. To put that in perspective, you could literally pick up the difference in weight. It was like removing two entire passengers from the car. And the engine debuted in the 1961 Buick Special, marketed as a compact car for the modern American family. Buick's advertising focused on fuel economy and smooth operation. They talked about grocery shopping and commuting. Racing? That wasn't even on their radar. The standard 215 produced a modest 155 horsepower with a two-barrel carburetor, or 185 horses with the optional four-barrel setup. Respectable for an economy engine, but nothing that would set the racing world on fire. The aluminum construction itself was a marvel of engineering. General Motors had learned from their earlier disasters with aluminum engines in the Corvair, which suffered from porosity problems and oil leaks. The 215 used a special aluminum alloy, 356T6, that provided excellent strength and heat dissipation. The cylinder walls were lined with iron sleeves for durability. The heads were aluminum too, with wedge-shaped combustion chambers and a compact valve arrangement, and it's tense. But here's where it gets interesting. The engine had features that Buick's engineers included for reliability and manufacturing efficiency, not realizing they had accidentally created the perfect foundation for a racing engine. The bore spacing was generous at 4.24 inches, allowing for significant bore increases. The bottom end was surprisingly robust, with a forged steel crankshaft and heavy-duty connecting rods that could handle far more stress than the stock power levels would ever produce. The aluminum construction meant exceptional heat dissipation, crucial for racing applications. And now enter Carroll Smith, a mechanical genius who would later become one of the most respected names in motorsports engineering. In 1962, Smith was working as Dan Gurney's chief mechanic. Gurney was already a rising star in racing, competing in Formula One and sports cars. But in the highly competitive world of West Coast sports car racing, they needed an edge. Carroll Smith had been studying the new Buick 215 with intense interest. While everyone else saw an economy engine, Smith saw something entirely different. He recognized that the power-to-weight ratio potential was extraordinary. Here was an engine that weighed less than most four cylinders, but had the displacement and architecture of a proper V8. The aluminum construction meant it could dissipate heat faster than iron engines, allowing for higher compression ratios and more aggressive tuning. Carroll Smith managed to acquire a 215 from a wrecked 1961 Buick Special. What happened next was pure mechanical artistry. Working in a small garage in Connecticut, Smith completely reimagined what the 215 could be. The first step was increasing compression. The stock engine ran 8.8.1 compression, conservative even by 1960 standards. Smith had custom pistons made that bumped this to 11.5.1, later going as high as 12.5.1. This alone required extensive machine work to the combustion chambers to maintain proper clearances. The cylinder heads received the full race treatment. Every intake and exhaust port was carefully enlarged and polished by hand. Smith spent hours with grinding tools, reshaping the ports to improve flow. The stock ports were designed for low-end torque and smooth idle, perfect for grocery shopping, terrible for racing. Smith's modifications increased port volume by nearly 30% while maintaining velocity. The valve seats were cut at different angles to improve flow around the valves. Larger valves from a Buick 401 were fitted, 1.875-inch intakes and 1.5-inch exhausts, versus the stock 1.72 and 1.34-inch units on an engine. But the real secret weapon was Smith's approach to the induction system. The stock 215 used a single 2-barrel or 4-barrel carburetor mounted on a conventional intake manifold. Smith fabricated a custom aluminum intake manifold that accepted 2 Weber 48 DCOE side draft carburetors. These Italian carburetors were typically found on exotic European sports cars, not American V8s. Each carburetor had 4 individual throttle plates, giving precise fuel metering for each cylinder. The Weber's accelerator pumps provided instant throttle response, critical for racing. The camshaft was another area where Smith's expertise shone. He worked with Iskandarian racing cams to develop a custom grind specifically for the 215's unique characteristics. The cam profile had to balance the engine's lightweight rotating assembly with the need for high RPM power. The final specification featured 312 degrees of duration on the intake, 320 on the exhaust, with 0.525 inches of lift. The overlap was aggressive, creating that distinctive lumpy idle that screamed race engine. The exhaust system was equally exotic. Smith fabricated custom headers with equal-length primary tubes, each precisely calculated to create the optimal scavenging effect. The primaries were 1.6 and 25 inches in diameter, stepping up to 3-inch collectors. The entire system was ceramic-coated inside and out to reduce heat transfer and improve flow. The ignition system received similar attention. The stock points-based distributor was replaced with a Vertex Magneto, aircraft technology in a car engine. The Magneto provided a consistent, powerful spark even at the 7,500 RPM redline Smith was targeting. Remember, this was an engine designed to cruise at 2,500 RPM on the highway. Gen-N cooling was critical. The aluminum engine dissipated heat well, but Smith's modifications generated far more heat than stock. He fabricated a custom aluminum radiator with 40% more capacity than stock, paired with an electric fan controlled by a thermostatic switch, advanced technology for 1962. The oil system was upgraded with a high-capacity pump and an external oil cooler mounted in the airstream. The bottom end required surprisingly few modifications, testament to Buick's over-engineering. Smith had the crankshaft balanced and knife-edged to reduce windage. The connecting rods were shot-peened for strength and balanced to within half a gram. The main and rod bearings were replaced with race-spec units that could handle the increased loads. When Smith fired up his creation for the first time, the results were staggering. On the engine dyno, the modified 215 produced 298 horsepower at 6,800 RPM and 245 pound-feet of torque at 5,200 RPM. Let that sink in for a moment. From 215 cubic inches, Smith had extracted nearly 300 horsepower. That's 1.39 horsepower per cubic inch, a specific output that wouldn't become common in production engines for another 40 years. To put this in perspective, the contemporary Chevrolet 283 cubic inch V8 with fuel injection, the most powerful small block Chevy offered, made 315 horsepower, but it displaced 68 more cubic inches and weighed 550 pounds. Smith's 215 made nearly the same power from far less displacement while weighing 232 pounds less. The power-to-weight ratio was revolutionary. The first race test came at Riverside Raceway in Southern California. Dan Gurney's Lotus 19 had been running a Coventry Climax 4-cylinder engine, sophisticated but lacking the torque to compete with the V8-powered competition. Smith and Gurney somehow shoehorned the 215 into the Lotus's tiny engine bay. It was a tight fit, but the aluminum V8 was actually lighter than the iron 4-cylinder it replaced. The transformation was immediate and dramatic. Where the Lotus had struggled out of Riverside's slow corners, it now rocketed forward with V8 torque. Down the long back straight, the car was suddenly 10 miles per hour faster. But the real advantage came in the handling. The lightweight engine meant the car's overall weight distribution improved. The Lotus could brake later, turn in sharper, and accelerate earlier than ever before. Andy and Gurney dominated that first race, lapping the entire field, except for second place. The racing community was stunned. Here was an engine pulled from a grocery-getter Buick, modified in a small garage, embarrassing purpose-built racing engines from Ferrari, Chevrolet, and Ford and. But Smith wasn't done developing the 215. Over the next 2 years, he continued to refine his formula. Bore increases took displacement to 225 cubic inches. Different cam profiles were tested for various tracks. He experimented with fuel injection systems from Hilborn and Kinsler. The ultimate version, built in late 1963, produced 325 horsepower at 7,200 RPM, 1.44 horsepower per cubic inch from an engine you could lift by hand. And the competition took notice. Other teams started hunting for Buick 215s to modify. The problem was, Buick had already stopped making them. The 215 was only produced from 1961 to 1963. Buick's accountants had decided that the expensive aluminum casting process wasn't worth it for an economy engine. They had no idea what they were throwing away. Here's where the story takes an unexpected turn. In 1964, General Motors sold the entire 215 design, tooling, and manufacturing rights to Rover in England. The British company had been looking for a lightweight V8 for their luxury sedans and saw potential where GM saw only costs. The price? A mere $2.5 million. GM literally gave away one of the most advanced engines they'd ever designed, and Rover immediately recognized what they had acquired. Their engineers were amazed at the sophistication of the design and the quality of the aluminum casting technology. They put the engine into production for the Rover P5B luxury sedan, where it transformed the car's performance. But more importantly, they continued developing it. The Rover version of the aluminum V8 would go on to power Range Rovers, Land Rovers, MGs, Morgans, and TVRs for the next 40 years. Displacement eventually grew to 4.6 liters. The engine became legendary in British motorsports, powering everything from rally cars to offshore powerboats, all because Carroll Smith had shown what was possible. Back in America, Smith's racing success with the 215 had an unexpected consequence. Hot rodders and racers started hoarding the few 215s they could find. Junkyards were scoured for wrecked Buick Specials and Oldsmobile F-85s, which used the same engine. Prices for used 215s skyrocketed. By 1965, a junkyard 215 cost more than a new Chevrolet 327 pointed N, and the technical legacy of Smith's 215 development went far beyond just one engine. His approach to aluminum engine modification became the template for a generation of engine builders. The techniques he developed for porting aluminum heads, the carburetor combinations, the cooling solutions, all became standard practice in racing. Anchen Smith himself went on to become one of the most respected figures in motorsports. He became chief mechanic for Shelby American, where he applied his aluminum engine expertise to the Ford GT40 program. Later, he wrote a series of books on race car engineering that became Bibles for aspiring mechanics: Prepare to Win, or Tune to Win, and Arf Engineer to Win are still considered essential reading in racing circles. The specific innovations Smith developed for the 215 influenced engine design for decades. His demonstration that aluminum engines could handle high compression ratios and aggressive tuning helped push manufacturers toward aluminum construction. Today, virtually every high-performance engine uses aluminum heads, and many use aluminum blocks, technology that was considered exotic and unreliable before Smith proved otherwise. The Weber carburetor setup Smith pioneered became the standard for American V8s in sports car racing throughout the 1960s. The concept of individual throttle bodies for each cylinder, which the Webers essentially provided, is now standard on many high-performance fuel injection systems. BMW's individual throttle body systems, Yamaha's XYUP systems, they all trace their lineage back to approaches like Smith's. Let's talk about what made Smith's achievement so remarkable from an engineering standpoint. The specific output of 1.39 horsepower per cubic inch was extraordinary for naturally aspirated engines of that era. Even today, without forced induction, variable valve timing, or direct injection, that's an impressive number. The Honda S2000's legendary F20C engine, praised for its specific output, makes 1.25 horsepower per cubic inch, and that's with 40 years of additional technology. And the thermal efficiency Smith achieved was equally impressive. Aluminum's thermal conductivity is about 3 times that of iron. This means heat moves through aluminum much faster, allowing for better cooling and more consistent cylinder temperatures. Smith understood this and used it to run compression ratios that would have destroyed an iron engine. The ceramic coating on the headers was another thermal management innovation, reducing underhood temperatures while keeping exhaust gas velocity high. The bottom-end strength of the 215 was a happy accident that Smith exploited brilliantly. Buick's engineers had designed the crankshaft and connecting rods to last 100,000 miles of gentle driving. That same over-engineering meant they could handle the stress of competition when properly prepared. The forged steel crankshaft was particularly robust. Many contemporary racing engines used cast cranks that would fail under similar loads. The influence on British engineering culture was profound. Rover engineers, inspired by what Smith had achieved, continued pushing the aluminum V8's boundaries. They developed advanced casting techniques that allowed for thinner, lighter cylinder walls. They experimented with different aluminum alloys for different applications. The technology they developed influenced not just automotive applications, but also marine and aviation engines. The economic impact of Smith's discovery was significant too. The cottage industry that grew up around 215 modification and part supply generated millions in revenue. Companies like Edelbrock, Offenhauser, and Mickey Thompson all developed aftermarket parts specifically for the 215. Machine shops specialized in 215 preparation. Racing teams paid premium prices for Smith-prepared engines. But perhaps the most lasting impact was philosophical. Smith proved that innovation doesn't always come from big corporations with huge R&D budgets. Sometimes it takes an individual with vision to see potential where others see limitations. Buick's engineers weren't wrong. The 215 was an excellent economy engine, but they were thinking inside the box of their market requirements. Smith thought outside those constraints and saw what the engine could become. The story also highlights the importance of technology transfer in engineering. The 215's journey from American economy car to British luxury sedan to global racing legend shows how good engineering transcends its original purpose. The same qualities that made it a good economy engine, lightweight, compact size, thermal efficiency, made it a great racing engine when properly developed. Consider the missed opportunity for General Motors. If they had recognized what Smith saw, they could have dominated sports car racing with factory-developed 215s. They could have created a whole line of high-performance aluminum engines. Instead, they sold the technology to Rover for pocket change and watched from the sidelines as others reaped the benefits. The 215 story is also about the democratization of racing technology. Before Smith's breakthrough, competitive racing engines were expensive, purpose-built units from specialty manufacturers. Smith showed that with knowledge and skill, a production engine could be transformed into a race winner. This opened doors for privateer racers who couldn't afford exotic machinery. Today, when we see aluminum LS engines making 4-digit horsepower figures, or Ford's EcoBoost engines extracting massive power from tiny displacements, we're seeing the evolution of principles Smith pioneered. The idea that an engine's potential isn't limited by its original design intent is now fundamental to performance modification. The human element of this story is equally compelling. Carroll Smith wasn't a corporate engineer with unlimited resources. He was a mechanic with talent, working in a small garage, solving problems through ingenuity rather than budget. His success came from understanding the physics and chemistry of engines at a fundamental level, then applying that knowledge creatively. Gurney's role shouldn't be understated either. It took courage to trust an experimental engine in professional racing. Gurney's willingness to try Smith's creation and his skill in exploiting its advantages proved that innovation and driving talent could overcome conventional wisdom. The story of the 215 also reflects the cultural moment of early 1960s American racing. It was a time when individual innovation could still compete with factory efforts. Rules were looser, creativity was rewarded, and a clever mechanic could outsmart entire engineering departments. Smith represented the best of that era, technical expertise combined with practical innovation. Looking at modern motorsports, we can see how much has changed. Today's racing engines are designed by teams of engineers using computational fluid dynamics, finite element analysis, and millions of dollars in development. Yet the fundamental principles Smith applied, optimizing airflow, managing heat, reducing weight, increasing specific output, remain the core of engine development. The legacy of the 215 lives on in unexpected places. The current generation of turbocharged four-cylinder engines making 300-plus horsepower follows the template Smith established. Extreme specific output from small displacement through careful optimization of every component. The Ford EcoBoost 2.3, making 350 horsepower in the Focus RS, is a spiritual successor to Smith's 215's, and even electric vehicle development shows Smith's influence. The obsession with power-to-weight ratio, thermal management, and extracting maximum performance from minimal mass. These are the same challenges Smith tackled with different technology. The engineering mindset he embodied transcends specific powertrains, and that's now in the collector market for 215 powered vehicles today reflects their historical significance. A genuine Carroll Smith prepared 215 would be worth six figures to the right collector. Even standard 215s command premium prices. Rover V8s, the British evolution of the design, are highly sought after for restorations and custom builds. Now, there's something deeply satisfying about this story from an engineering perspective. It proves that good design is timeless. The 215 was advanced for 1961, competitive in racing through the 1960s, successful in production for 40 years, and still respected today. That's the hallmark of truly great engineering. Carroll Smith passed away in 2003, but his influence on motorsports engineering continues. The books he wrote codified the knowledge he gained from projects like the 215. Thousands of engineers and mechanics learned their craft from his writings. In a way, every aluminum racing engine today carries a bit of Smith's DNA. The Buick 215 story reminds us that innovation often comes from unexpected places. A mechanic in Connecticut saw what General Motors engineers missed. He took an economy engine and revealed its racing heart. He proved that with enough skill, knowledge, and creativity, you can outsmart even the biggest corporations. This story represents everything that was great about the golden age of American motorsports. It was a time when individual brilliance could triumph over corporate resources, when innovation was rewarded, and when a mechanic with a good idea could change the racing world. Carroll Smith and his secret 215 didn't just win races. They proved that the best engineering solutions sometimes come from looking at problems differently. The next time you see a modern high-performance engine with aluminum construction, individual throttle bodies, or impressive specific output, remember that it all traces back to a mechanic in Connecticut who saw potential where others saw limitations. Smith didn't just modify an engine. He revealed a truth about engineering that resonates today. The limits of any design exist mainly in our imagination. What's your favorite story of unlikely racing success? Have you ever seen one of these legendary aluminum V8s in person? Drop a comment below and share your thoughts on this incredible piece of engineering history. And if you enjoyed this deep dive into one of racing's best-kept secrets, make sure to subscribe for more stories of engineering brilliance and the innovators who changed motorsports forever.